Hello, so today we will prove an identity for the geometric series. And I guess the most well-known example of the geometric series is the one where we have 1 over 2 to the power of 0 plus 1 over 2 to the power of 1 and so on, and it looks like the one above here. And basically we want to show that this actually converges onto 2 and so much that it actually will become the number 2. Before we will work with this very specific instantiation of the series, we want to see what its general form looks like. It'll be something like this. Right, so we use the summation sign here, but it just means what you can see on this side, right? We have some real number that is not equal to 1, and we have a number in the exponent that we just increase until it reaches n. Okay, so for the proof, the first thing we do is we'll multiply this series with 1, because every fraction x over x just equals 1. So we can do this, right? Because 1 times something equals something. We didn't change anything here. So then we look at the numerator and we multiply the numerator with the series. And what we get is the series from above. We just said, okay, 1 times the series, nothing interesting happens. But on the right side, we have minus r times the series. But this is the same as if you take this r and put it into the summation sign. And what you'll get is every ri times r will just become ri plus 1. So we basically shift every summand in the series by 1. And this is exactly the same thing as if we just changed the limits in the series. So we could just write I equals 1 and n equals I equals 1 and n will become n plus 1. Okay, so we do this and it looks like this. Now what we can see is that this series starts with 0 and this one ends with n plus 1, but everything else will be the same. So we'll have r to the power of 2 in the first series, and we have negative r to the power of 2 in the other series. And all those terms cancel out, and the only unique terms are the one with r to the power of 0 in the first series and r to the power of n plus 1 in the second series. So we'll get this term. And r to the power of 0 is just 1. Okay, so we have found this identity. It's very nice identity for the geometric series. Now let's look what happens if we use it on our example above. Right, we plug in 1/2 for r. We get 1 minus 1/2 to the power of n plus 1 divided by 1 minus 1/2. Now we say, okay, what happens if we send n towards infinity? Well, 1 over 2 to the power of something as a series converges towards 0, and so if we say, well, n is infinity, we can just plug in a 0 here. So this term basically just cancels out for n towards infinity. Okay, so what we're left is just 1 over 1 minus 1/2. And this is the same as just 1/2. And this, indeed, 1 over 1/2 just equals 2. And this is basically what we wanted to prove.